Okay, so now we're almost ready to turn, I guess. 13. Apply movement and rotation to your character. You're almost done. The final step is to apply the movement and the rotation to your character. There are many ways you could do this, but since the character needs to be part of the physics system, you need to move the rigid body instead of using any other technique. In order to do this, you need a reference to the rigid body component. You can get this exactly as you did for the animator component. Add the following line to your script immediately after the animator variable declaration. Okay, so immediately after. All right. So rigid body, M rigid body. That's the name of the variable. Okay, we're gonna save it. Add another line of code just after setting the reference of the animator variable. Add another line of code just after setting the reference of the animator variable. Oh, so wherever wherever M animator is down here, okay, so it's like the same thing. It's like M rigid body equals get component rigid body, like that, and boom, boom. All right. Now that you have a reference to the rigid body, let's think about the specifics of moving the animated character. The character has a fun walk animation, and it would be good to use the root motion for that. However, the animation doesn't have any turning in it, so if you try to turn the rigid body to update in the update method, it might get overridden by the animation, which could lead the character to not turning when it should. You actually need is some root motion of the animation, but not all of it. Specifically, you need to apply the movement, but not the rotation. So how to change the root motion is applied. So how to change how root motion is applied to the animator. Luckily, Mono Behaviors have a special method that you can use to change how root motion is applied from the animator. Below the update method, declare a new method. Okay, so below update, we're going to do a new method called void on animator move. Apparently, it's auto set in there. Method allows you to apply root motion as you want. That means that movement and rotation can be applied separately. Okay. So. Okay. Movement. Let's start with movement. Add the following line to the new onAnimator move method. Okay. M rigid body dot move position. If you're wondering why I'm not typing out this full thing, it's because there's autocomplete, and so I just have to type in a few things, and then when it pops up, then I hit enter. Usually it's the top one. If you need to get to a different one, you can use the arrow keys or whatever to select it. Move position, open parenthesis, M rigid body dot position plus M movement times M animator dot delta position dot magnitude. Okay, since this is a long one, I want to actually go ahead and, how did I do that before? I said equals and then, right, so this is what I did here. Alright, go ahead and put this in there too, and I'm going to do that because that's the way I like to do it, unless it complains, but it shouldn't complain because it's just a white space in between there, and we got a semicolon, so it's the end of statement, so everything should be cool. Another fairly complicated looking line of code, but again, there's very little that's completely no to you here. First, you're using the reference to your rigid body component to call its move position method and passing in a single parameter its new position. The new position starts off with the rigid body's current position, and you've added a change to that. The movement vector applied by the magnitude of the animator's delta position. What does that mean? The animator's delta position is a change in position due to root motion that would have been applied to this frame. Since you're taking the magnitude of that, the length of it, and multiplying it by the movement vector, which is the actual direction we want the character to move. Alrighty. Rotation. Next we apply the rotation. Add the following line just below move position call and the on animator move method. So, M rigid body dot move rotation. See, I arrowed down there. M rotation, and that's all she wrote. This is very similar to the move position call, except it applies to rotation. This time you're not applying a change to rotation, you're just directly setting the rotation. This is the last line of code in your first script, but there's one more thing you need to adjust. So let's see what that one thing is and see if we can get some turning going on. Change your update method. In the previous tutorial, you learned about the update loop used for rendering and the fixed update loop, which runs physical operations. I don't know if it told... supposedly it did, but I don't remember if it told about fixed update for physics. You've made sure that the animator runs in time with the physics loop to avoid conflict between physics and the animation. However, now you're overriding the root motion using onAnimator move. That means that onAnimator move is actually going to be called in time with physics and not with rendering like your update method. The movement vector and rotation are set in update. If onAnimator move gets called first, then you will have a problem because a quaternion without a value set doesn't make any sense. Make sure the movement vector and rotation are set in time with onAnimator move. Change your update method to fixed update method as follows: void fixed update. So all I have to do is add a fixed to it. This is another special method. It's called automatically by Unity, but this one is in time with the physics. Instead of being called before every rendered frame, fixed update is called before the physics system solves any collisions and other interactions that have happened. By default, it's called exactly 50 times every second. That's it. The completed script should look like this. And I guess I can do this. Okay, so player class movement, mono behavior, float speed, M animator, rigid body, vector 3, quaternion. Starts got animator, M rigid body, fixed update, get access, movement set, movement normalized, has horizontal input, has vertical input, is walking, desired forward, which I actually split up into 3 lines, M rotation equals quaternion dot look rotation. Okay, on animator move, interesting. M rigid body dot move position. Okay, and then there's all that. Oh, I see. It's in here too. I just put a space in between M rigid body dot move rotation. Okay, so everything looks good except, let's see something here. Public class, void start, void fixed update, void on animator move. So this one says it's private. I'm going to set it not to private because it's not in the code there. So we're going to save it like that and hope everything works good. Remember, in C#, the order in which the order methods are declared in a class doesn't matter, so your methods may be arranged slightly differently. Save your script and then give yourself a hearty pat on the back. Now it's time to go back to Unity and test your work. In which case I probably have screwed something up and I won't be able to use it, but I'll have to fix it or something. But we will see. 17, test your changes. Add the player movement script to John Lemon. Once you've returned to Unity, you need to add the script to John Lemon as a component. You can add the script components by clicking Add Component button in the inspector window, but you can also do this another way. Select the John Lemon game object in the inspector window, click Edit Prefab, enter Prefab mode. Okay, so it's going to be on the prefab. That's kind of what I thought, and I was kind of hoping it would tell me. So, let's see. John Lemon Game Object. Where is it? Open Prefab. How come it's not showing the prefab here? That's interesting. Well, I gotta make sure that I am somehow in prefab mode, so let's go to the actual prefabs. Let's go to John Lemon. Save changes I made in prefab mode. I guess save them. Hopefully I didn't screw something up. How come? What is going on here? How come I'm not in prefab like edit mode now? See, now I've just gone into the stupid next video here. What? Scene. What in the heck? You know what? I'm going to do this. And actually, I'm going to stop this video, and we're going to go to the next video. So that's just the way that's got to be. It's actually okay. I don't know why. That little thump sound was actually a boxing thing that I was using.